Okay, so I'm getting a little ahead of myself. Let's take a step back. When we last left off, I was having some trouble coming up with a table. Well, my treasure hunt didn't last very long. I came across some really nice cold rolled steel, 3/4 of an inch thick, almost 4 foot long, and they were considered cutoffs, so the price was spectacular. So here's what I thought I'd do. I'd use 2 heavier pieces to make the connection between the pair of skates on each linear bearing, sort of in the Y direction. And then use the 3/4 inch CRS to make slats that bridge that gap in the X direction. So now the only thing standing between me and a table for my CNC, well, was about 500 more drilled and tapped holes. So now that I had a plan for a table, I could start working on the screw mounting brackets. I mean, there's really only just one big one, the flange that the motor also mounts to. The other side's just a small flat weld tab, essentially. That bent rod you see holding the gussets is really just that, a bent 1/4 inch rod maybe. It's called a helping hand or a third hand. A second hand maybe, depending how long you've been in the hobby. And the bracket's just welded onto the back of the table, somewhere in about the middle. So the Y-axis screw lives right in here. There's the second ball nut carrier, attaches underneath the table. Now in order to locate this, I'm going to have to set the rails up, and I'm going to use the table to dictate the position of the screw. I have a granite square on that carrier plate and an indicator mounted in the spindle collet. I'm seeing about 15 thou deviation from left to right. That's 8 inches maybe. And the indicator movement is a little bit lumpy. There's something going on in the gantry still. But one step at a time here. Once I had both rails on there loosely, I set up an angle plate, indicator, and plenty of clamps all over the machine. I used those to tune in, I guess what I'm calling my reference rail, the rail that the rest of the table will be based off of. And I don't know if I'll regret this, but when I was happy with that rail, I welded it in place. A couple of pins would have probably been fine. I gave it a quick once over with a level to make sure I hadn't screwed anything else up. And at that point I felt comfortable locating the Y screw. I started drilling from the bottom where the transfer marks were, but after 2 holes that got old fast and I moved to drilling from the top. Once that end was in, I moved the ball nut to the other side and did the same thing, except there I opted for small pilot holes from the bottom and all the drilling from the top. My battery quit here on me and I went into manual tapping mode. Once the screw was in, I located the nut to the bottom of the table. And just like the gantry, I closed that gap with some shims. So I have 2 Sanyo motors and an Astro Syn. I've had some trouble finding the data sheet for this motor. It's physically bigger, but from the limited information that I found, this actually has less torque. Now I'm going to try this under the table, just because everything else is wired, but it's highly likely that I'm going to swap these 2 motors out. The Z-axis is the lightest, so that seems like the smartest place to put my lower power motor. Now if you plan on making one of these things yourself, do yourself a favor. Give yourself a lot more space than I did. So I've got the table motor wired in, and it looks like it's moving. But before I do too much fooling around or go any further, I need to get a heat sink on these motor drivers. I've got a nice chunk of aluminum that I think will do just the trick. So the drill chuck on my mill won't close down on small diameter bits. I've always meant to do something about that. Drill press should work just fine. So these geckos have essentially like a current limiting resistor or a current set resistor. I'm going to change these out and run them all at 6 amps for now. See how things go. So everything seems moving pretty okay. You're looking at the table, just spin through some circles. I've got it set to 200 inches per minute, and it doesn't look too bad. I'm not too happy about the acceleration on the table. I think I'm going to try to swap these motors out. So the Y and the Z motors have been swapped, the table and the spindle. I really didn't realize how much of a dud this AstroSyn was. I don't know if it's just old or underpowered. I don't know if this comes across on TV, but the accelerations for the heavy table are a lot better now. World of difference. These are the same circles I was running before. If the motions look a little erratic, it's because it's running the program at rapid speed everywhere. But I wanted to see how it handled higher accelerations. I'm much more concerned about the acceleration on all 3 axes than I am top speed. So what I did was set all 3 axes to 200 inches per minute and then tune the acceleration up from there. I've almost got all 3 accelerations matched. The Z-axis is still giving me problems, so I think sooner or later I'm going to update that stepper. So I've been screwing with the table and running those circles for the better part of a couple hours probably, and I've been keeping an eye on the temperatures for the stepper drivers. Now the heatsink's just choked off and sitting on top of a wooden board. X and Z are a little bit cooler. Y is peaking at about 35 degrees, which makes sense since Y is driving the highest load. That table is now currently swinging over 120 pounds, and it's only going to get heavier from here on out. I'll share some of those numbers and details with you a little bit later. They were important to me, maybe to give you a better ballpark idea of what these amperages and torque ratings are capable of. So I got most of it's called what I think is the dull work, done this past week and a half or so. And that mostly consisted of putting a coat of paint on the machine, building up an enclosure, and getting all the electronics mounted inside. It's basically 2 pieces of bent sheet metal with some tack welds, and for now I'm going with some clear acrylic for the front panel. You see I still have a little bit more work to do there. The controls and the inverter are on my side, and then all the connections are made in through the back. For now though, I think I'd like to turn my attention to the top side. Get some of that wiring and the guards on, start to button that down, and work my way back to the control box, just straightening everything out as I go along. So to close up the gantry, I'm going to go with some bellows along the x-axis, and they're going to live inside these 2. These are little U sections, tack welded to some flat sheet. I've got the bottom one mounted. I'm just going to drop the top one in, and I'll have the bellows ride in those tracks. A couple of screws in that side and a couple of screws in the Z-axis. I'm not actually going to install this just yet. I still want access to these rails before I close everything up. Now the back side of the X-axis, all along the gantry, gets a classic cable carrier. In order to mount that, I've just drilled and tapped a couple of holes. And that'll take this essentially like a gutter. Just folded up a piece of sheet metal, welded some mounting flanges on it. On this other end, the track just goes to a plastic cable tray for the vertical leg. I spray painted this black. I could only find them in white. And then once I run the cables through, These get sort of their own puzzle piece caps to do all the bends. And those will get painted too, of course. So the enclosure is probably not the best design in the world. I moved essentially everything you saw on the table earlier onto a sheet of MDF and then mounted the MDF into the sheet metal box. That includes the inverter. That's probably not a great place for it. There will be a cutout in the acrylic to access the face, but I am a little worried about that thing overheating inside of that box. I mean, there are a couple of fans and it's got its own fan, so I do have some air moving in there. I just don't think that's how they officially get mounted. That thing, however, it's a Huan Yang, came with the spindle. Complete piece of junk. I mean, it turns the spindle, it's moving, but if how the buttons feel is any indication of how the rest of the thing is built, I don't expect that to last a month, maybe two. I tried to keep it as neat as possible, the wiring I mean. I've got power here, an emergency e-stop, and I don't have a knob for it yet, but I have a panel mount potentiometer that should control my spindle speeds. And I've got a range from 7,200 to 24,000 RPMs, which is way too fast for me, but it'll do for now. Little red button is lights under the gantry. Other than the buttons and the fans, I think the only new addition are the power supplies. There's a 5 volt, a 12 volt, and a 24 volt. Alright, so now that I got that out of my system, let me get you caught up with where I am. I've got all the wiring more or less buttoned up. You can see the bellows are in the gantry. I put in like a rubber guard, just some rubber sheeting in the back of the table. We'll go around back, I'll show you how that's hooked up. And there's some clear plastic shields that'll box this whole thing in. The shields just drop into some tracks welded to the frame on all 4 sides, and they sort of lock together when all 4 of them are in. To be honest, that's more to help keep my kids' hands out of the machine, though it's a bonus if it helps keep the mess down. So I've got the same plastic sheeting in the back, and the rubber sheet is just sort of fed through some round tubing, and it floats on the frame, you know, as the table needs it to move back and forth. And the bellows seem to be working out all right. I plan to use the same rubber sheeting on the front of the table, but I haven't gotten that far. I'm still missing one of the table slats, let's call it. But it's the same concept. It'll attach to the leading edge and fit down between the offset tubing and the frame. The table can feed in and out as it moves. Something else I try to do on each axis is to leave a bit of a gap, at least an inch between all the moving and the stationary parts. If for some crazy reason the guards aren't installed and someone's got their hand on the machine, at least it won't create a pinch point anywhere. So let's take a shot at this thing's first real project. I've got some 1.5 millimeter steel sheet I'd like to turn into essentially a belt guard for the X-axis. had the sheet metal stuff out, figured it was a good time as any to build the guard for the Z-axis. This is the same 1.5mm sheet, about a 1/16 of an inch. And you know, it only dawned on me later that I had a CNC router I could have used to cut this out. My sheet metal brake is pretty simple, just 2 pieces of angle iron, a couple of hinges and 2 handles. I find this style really useful. I mean, not as convenient maybe as a finger or box brake, but if you're willing to get creative with setups, they can really do a lot. That's a 9-inch deep bend you're looking at there. And I can just throw it in a corner when I don't need it. At this point, I really wanted to see what this thing could do. I'm still getting up to speed with Fusion, figuring out feeds and speeds, all that stuff, and getting back up to snuff with Mach 3. Let me tell you, I've been making my fair share of bonehead mistakes, but it's getting better. I started with a simple slot in aluminum, starting with a 4mm cutter and some light cuts and moving my way up to 8mm and more aggressive feeds. I tried both 2-flute and 4-flute high-speed steel end mills. I'm still waiting on my carbide, but they're doing pretty good. What you see here is standard 2D profiling with an 8mm 2-flute. This is about 32 inches a minute and 1/8 depth of cut. The chips look good and the cutter seems no worse for the wear. And this instead is 2D adaptive. Just roughing passes, no finish cut. Though this one could have really used it. Although that pretty much wraps things up, it doesn't quite feel right ending this without some sort of payoff. Without actually making something. I knew I wanted to make something for my boy, but wasn't exactly sure what. And after a lot of looking around, I eventually settled on a multi-shot lever action rubber band rifle. There are a handful of parts here, mostly aluminum and some wood. Let's dig in. The receiver is built in 2 pieces that'll be screwed together. This is the first half. Each completed receiver side, inside and out, took about an hour and a half start to finish. I used pins to key my stock to the table, and indexing and alignment turned out pretty good. components for the inside were machined at the same time. I mean, out of this same aluminum plate. And this is side 2. Getting the parts out wasn't bad. I cut the tabs or bridges with a small saw. It didn't take much to get them free. I removed the tool marks on the outside of the receiver with some sandpaper. Though I've got plenty of deburring to do, I couldn't resist a quick fit up. The lever is a bit loose. I think that's my fault, but everything else is looking pretty good. Compared to all those small aluminum parts, this wood turned out to be a walk in the park. This is just some pine, and I do regret not using something maybe a little bit better. I made a simple barrel band / muzzle cap. It holds the barrels in place and creates the hook for the rubber bands. It's just Loctited in place. Assembly went surprisingly well. Only had to take it apart 2, maybe 3 times, mostly to deburr a spot that I'd missed, or a spring might rub somewhere, or just a set screw turned out to be a hair too long. I used a food-grade PTFE grease on the insides, because, you know, a 4-year-old, sooner or later he's gonna eat the thing. Seemed to work pretty good, but it's finicky about rubber bands. It wants just the right ones. I think the fit and finish could have been better. Heck, I might just make one of these for myself. I bet brass would look really nice. But anyway, no complaints from the customer. And one last thing, router design. I know I've made some promises, and I did get into it, but honestly, it was really slow, and I wasn't sure how much audience appeal it really had, so I cut it out. That said, though, let me know if you're really interested, and I'll do a separate video just on that topic. However, lots of folks have asked me for the CAD, so I'll provide a link to that in the description below. I'll put it up as a step file. I think you can open that with just about any software. One thing to keep in mind, though, there aren't any drawings. And unless you have all the same components I do, the CAD should really only be considered a starting point if you like this design. You'll have to make updates based on your needs, comfort level, equipment, and hardware, of course. But you'll have the overall dimensions. That said, I'll give you what I think are the two most important pieces of information here. First, the frame is designed to minimize the deflection under a 50-pound load at the tip of the cutter, mid-gantry, at full extension. On paper, it's about 1 thou, and I have no idea how close that 50-pound guess is to real life, but I bet I'm safe for this size machine. Second, and this is the info I was really looking for when I started, a 5 Newton 6 amp stepper, that's about 700 ounces, through a 5-to-1 lead screw, or a 5-to-1 mechanical advantage, can move upwards of 100 pounds at 200 inches per minute easy. And like I said earlier, it could probably do 200 without a problem. So that's it. Thanks again for watching. I hope you liked it, and see you next time.